Hello, my name is Justin Chow, and I'm going to be presenting RTDSP Project 2. So for this first video, I'm going to start by doing the first task in Project 2, which is going to be a winDSK demonstration, sections 3.2.1, 3.2.2, and sections 3.2.3. So winDSK is an inbuilt application for our RTDSP board that already has the effects coded in with a nice interface, and is mainly going to be used for demonstrating the effects that we will later design ourselves using Code Composer. So section 3.2.1 talks about using the graphic equalizer. So we can open up the graphic equalizer by clicking here. And right now I have the sound on. And what's playing in the background is a 1 kilohertz sine wave. So the graphic equalizer interface is built on low-pass filters, high-pass filters, and bandpass filters. So the in-between filters are bandpass filters. This first filter is going to be a low-pass filter, and this last filter is going to be a high-pass filter. Now, they're labeled as center frequencies, and that's true for the bandpass filters. So the bandpass filter has a center frequency around 2K, 4K, and 8K here. But for the low-pass and high-pass filters, these represent the cutoff frequencies. So that means for this low pass filter, the cutoff frequency is around 1 kilohertz. So the 1 kilohertz sine wave signal will be controlled by this slider. So if I change these values, I can make the signal louder, or I can make it silent by adjusting these sliders. Now since the signal's in this band, changing the sliders in any of the other bands will not affect the volume of the sounds. As I turn down all the other bands, nothing is changing to the signal because the signal doesn't fall within these bands. So this is for a 1 kilohertz signal. We will now try using a 2 kilohertz signal by going over here. And I'll now run a 2 kilohertz signal. So this is a 2 kilohertz signal. So if I open up the winDSK interface, I can increase the volume of it using these sliders. And now these sliders don't do anything. See how I can increase the volume. These sliders. Changing the other sliders doesn't change the effect of the noise because it is not within those bands. So since the center frequency is around 2 kilohertz and the cutoff frequency of this first low pass filter is 1 kilohertz, that means this has a bandwidth of about 1K because it will extend down from 2 kilohertz around to the end of this band, to the end of the first filter at around 1 kilohertz. And will extend 1 kilohertz upward to 3 kilohertz over here. And then the next band above that, the 4 kilohertz band, will reach down to about 3 kilohertz here and 5 kilohertz on the other side. It's 1 kilohertz bandwidth as well. This next band over here, 8 kilohertz bandwidth, will extend down from 8 down to 5, which is 3 kilohertz here, and then another 3 over here, which will take us up to 11. And then this one over here will take us 17 down to 11, which is 6 kilohertz over here, and then another 6 kilohertz on the other side, which is 23, which will get us close to 24 kilohertz, which is the max Nyquist frequency, since my sampling rate over here is 48 kilohertz. So this is the graphic equalizer. I'm not going to demonstrate the other higher frequencies because as the frequencies get up, the pitch gets higher and it can get hard to hear audibly and it can cause headaches. So with that in mind, we're going to move on to the next section, which is section 3.2.2. Section 3.2.2 is where we're going to use the winDSK to demonstrate the notch filter. So we're going to close out of the graphic equalizer. We're going to open up the notch filter. So I'm going to run the 1 kilohertz sine wave again. And right now it's going to pass through because, and also this filter type right now is bandpass, but we're going to switch this to notch. Right now the notch is set to 2 kilohertz, so the 1 kilohertz signal that I'm playing right now will pass through without any issue. But if I change the center frequency to 1 kilohertz, now the signal is at the notch frequency, and so it is notched out. So even though the signal is playing, it's attenuated to 0. We can also use this Q adjustment of this R factor. So by increasing this R factor up to 1, notice how now the notch filter doesn't appear to be working very well because the sound is still passing through. Similarly, if we take this all the way down to 0, then nothing you still get nothing. So this is what the notch filter does. So if I change it slightly, so now that it's about 1500, you can still slightly hear it. But if I decrease this R value, and then I can increase this R value. So since it's close to the notch frequency, it still gets attenuated slightly. As I increase this, I can make the sound go back to its maximum volume. But since it's near the notch frequency, it still gets attenuated because the notch is not a perfect notch, it curves. So this is going to be the notch filter. So the next section after the notch filter is section 3.2.3. Section 3.2.3 is where we're going to discuss some of the audio effects. Now, the different audio effects are important to demonstrate on the winDSK8 to understand what the different parameters are, because we'll be programming some of these effects later. So the first effect that we're observing right now is direct, and direct is the same as talk through, just basically passes a signal through with no attenuation, no special effects. Next is echo. Echo causes, well, an echo. You'll hear a delayed version of the signal, and echo uses a fixed delay, which is controlled here in analog. Right now, the delay is set to a very low amount, about 10 milliseconds, but I can increase the delay so that way you can hear the delay longer. Well, you can't hear because I need to increase the reflection, which is the actual volume of the echo. So now the echo is a lot louder, and this changes the delay of the echo. I'm going to skip chorus for a bit and go to the flanger effect. So the flanger effect basically is like echo, except that the delay will change with time, which will create oscillations. So this frequency slider will change to the frequency of the echo, as you can see right here. And here, as I increase the frequency, you can hear the oscillation start speeding up. This delay changes the maximum delay of the changing delay, because the flanger effect is like the echo effect, but the delay is not fixed, instead it will change. But this will change the maximum amount of delay. So if I increase the maximum delay, you can see that the effect changes, that the waving sound gets louder, and you lose the original signal more as you increase the delay. But if you keep the delay low, you can still obtain the original, you kind of hear that original tone. This alpha right here affects the gain of the echo. So I can do this to make it quieter or louder. Flanger also comes with this wow button. So by disabling wow, by enabling wow, you keep the original signal. But when you remove wow, the effect changes slightly. So with wow enabled, you lose the original tone, but when wow is disabled, you get the original tone overlaid on the echo. So here we have without the wow, so you can hear the original tone riding on the echo. And with wow enabled, you lose the original tone and just hear the echo. Chorus is a specific type of flanger effect with 3 flanger effects that create a sort of echo. There are no controls on the winDSK for the echo. So unfortunately, you can't control the chorus effect, but it's going to be 3 flanger effects that are really close together to sound similar to an echo. The tremolo effect causes the signal to reverberate. So you can change the frequency of reverberation using this slider. So you see with increased frequency and with decreased frequency, with a low frequency, you can hear the pulsing back and forth. And this depth will control the volume of that pulsing. This also comes with an extra feature called double sideband suppressed carrier. So without the double band suppressed carrier, you hear the pulses, and with the double band suppressed character, the pulses are weaker, but you hear the original tone. Next is frequency translation. So frequency translation shifts the frequency. So if I do this, I'm decreasing the frequency, and this makes the tone higher, which is increasing the frequency. And the last effect, and then there's also the karaoke effect, which I'm not quite sure what it does, and there are no controls for it. And there's the subharmonic effect, which has the subharmonic gain, which you can increase that, and you can also increase the delay. And these are the audio effects that the winDSK8 has that can provide. The main ones that we're going to be focusing on are the flanger effect, which uses these controls for frequency oscillations and for the amount of waving, and then the chorus effect. We'll discuss those in depth later. And that's the first part of this project, which focuses on just the winDSK8 demonstration, just demonstrating these different effects that we'll eventually program in later projects.